Hello, everyone. So this is the last structural pattern in the list of structural patterns we're going to talk about. There are more structural patterns out there, but we're just going to talk about these two very important ones right here, the two most commonly used ones. So this is also the last design pattern that we're going to talk about, and this will probably be the last video that you're going to see in this course. So let's get to it to finish all of this. So this is the adapter pattern, and as always, we're going to start with the problem. So the problem, as your system evolves, you will likely encounter interfaces of instances that are incompatible with their intended clients. The reason why these interfaces become incompatible, even though they perform the necessary behavior, could be because the method names are just different. Let's say this client right here expects to use this interface by calling this particular method name, but it just so happens that the method names are different. And this can happen quite a lot since the interface of the dependency that is incompatible for your new client may be originally built for a different reason. So if you have a specific uh, instance, for example, I'm calling this instance A, and you want to use this instance A with an interface called I, but it is incompatible because the methods inside A right here are named different from the methods inside I. And that could happen because A could be used by someone else. It could be a client right here that is using this A right here using a different interface. So this happens quite a lot also if you're importing this specific dependency right here on existing client code. It is an external module that you didn't code, and if you import it and you're expecting to use it this way, you cannot use it because it has different method names. The author of that named it differently. So what you can do to solve this is you can change the incompatible interface to support the functionality you need. So what you can do, let me scroll down first. What you can do is the method names that make this incompatible should be changed so that it is now compatible to the interface that you want it to be used as. So you change it into different names so that it can be used like this interface right here. But the problem with that though is that it will make this incompatible with the other clients that use it. So this client C right here, which is currently using it, it may be somewhere else in your system that you have forgotten that uses your uh, class right here. It will pose, or it will result in incompatibilities for that relationship right there. By changing those names right there, you may have introduced errors to some other part of your system because this client right here is expecting this dependency to be used a particular way. Changing it will, of course, affect other things in your system. So, what do? You can create multiple copies of the same function, but you're just using different names. So the first function right here would be named this way. The other function, which does the same, would be named this way so that it's compatible for both this one and this one. So the problem with that is, of course, it will introduce code duplication, which is, of course, not good since multiple instances of the same behavior is not good for maintainability. When you do start to change the contents of that method, you would have to change all of the copies of that method. So the solution here, of course, is the adapter pattern. But before we move on, let's think of an analogy here. So let's say you have some laptop, for example, and your laptop right here has a HDMI port. And you want to connect your laptop right here to a specific dependency. This dependency is your projector, for example. So this projector has cables, but the ends of the cables are VGA. So even though that both of these ports and cables right here are intended to be used for a similar manner, they're intended to transmit visual information between each other. The problem here is that they are incompatible because their ports do not look the same, they don't have the same number of pins, for example, and etc. So this is an incompatibility that arises because your laptop is expecting some interface, but the only thing available to you is a different interface. You want your laptop to accept something of the HDMI interface, but you only have this VGA interface right here. So what do? Do you chop off this wire right here and replace it with an HDMI end, right, Lat? But if you do that, what about other devices that are expecting your projector to be used with the VGA port? So you have an older laptop right here, for example, and this older laptop does expect a VGA cable to be plugged into it. So you would have made this incompatible with this now HDMI interface right here. So no matter which interface you choose, HDMI or VGA, it would be incompatible for one of them. So the solution for this, I'm sure you've encountered this problem right here, is instead of replacing the ends of the cable with different interfaces, you create this adapter right here. And an adapter, what would it look like? So this adapter, for example, would have this VGA port in one end, and on the other hand, it would have an HDMI cable. And by plugging the VGA cable from the projector to the adapter, and by plugging the HDMI cable from the adapter to the laptop, you can now transmit visual information without incompatibility. And if you do want to use this for some older laptop, some older dependency, then you can just remove the adapter and just plug in the VGA directly. So you do the same thing for object-oriented architectures as well. And this is the reason why this is commonly used, this pattern right here, because this problem appears quite common in legacy systems, in older systems that you want to be repurposed for new services, for example. So of course, the solution is the adapter pattern as well. It has the same name as the adapters that you use for these physical wires and ports. So in the same way that the USB-C interface is usable in a USB 2, so I've used a different example in my lecture notes right here. So you can use an incompatible service on a client as a compatible instance using an adapter pattern, in the same way that we use the adapter right there to connect the projector to your laptop. So say you have an instance of an abstract service. So this abstract service right here, it could be any realization of abstract service that needs to be used like an instance of required interface. So example of this, so this required interface right here would be the HDMI cable. You're expecting an HDMI cable. You're requiring an HDMI cable to be plugged into your laptop. But you only have an instance of VGA cable. So it could be any it could be connected to, it could be any appliance, or it could be anything. It could be a monitor, it could be a projector, but it is a VGA cable disconnected through a VGA cable. So what you need to do to support this VGA cable and make it act like an HDMI cable is to create an adapter to abstract service called service adapter. And this service adapter right here will be your, of course, adapter. Your VGA to HDMI adapter. So this VGA to HDMI adapter, or this service adapter, realizes required interface, meaning you use it just like you can use this VGA adapter, VGA to HDMI adapter, in the same way you use an HDMI cable right here. It is a realization of this abstraction right here. So to adapt the instance of abstract service right here, what you do is you compose this abstract service into the HDMI adapter. Meaning, you plug it in or you make it an attribute of this specific class. So you have to compose it inside service adapter so that the incompatible methods are adapted to your compatible methods. So for example, service method 1 right here is now adapted into method 1 since you're requiring this specific adapter to be used as method 1, but you only have service method 1 for your dependency. So let's look at the class diagram for this one. So you have here the following classes. So this is your real service right here, which is currently used like an abstract service. Abstract service are named service method 1 and service method 2. These are the names for the methods inside it. But it is incompatible for your client because your client expects it to be named method 1 and method 2. So what you do, so you want this real service to look like a required interface, to act like a required interface. So you can't just change these names right here because changing these names would affect all of the dependencies that are currently depending on this abstract service right here. So what you do instead is you create this service adapter right here. And this service adapter will realize your required interface, meaning it will be treated as your required interface. But the special thing about this service adapter, by the way, this required interface should be I right here since it is an interface. So this service adapter right here, since it realizes required interface and required interface are expected to be named method 1 and method 2, that's the expected names of its methods. So it will also be forced to realize that. And at the same time, this service adapter will contain a reference to your abstract service right here, because this service adapter right here needs to be able to call the service methods of your abstract service. So for example, all you have to do inside method 1 right here is just to delegate that behavior to service method 1 by calling service, which is attributed here, service dot service method 1. Inside method 2, all you have to do is to call service dot service method 2. And by doing that, you have disguised your real service to act like required interface. Okay? So it's described right here in the lecture notes. When a service adapter calls method 1, it instead delegates the behavior to the embedded service, which instead calls service method 1. So before we move on to the example, let's look at the code for that class diagram right there. So you have here abstract service right here, which contains the following service methods, and you cannot change them again because they might be dependencies for some clients, which will become incompatible if you replace them with different names. And let's say this is one of the realizations for your abstract service. You have real service right here, and just to signify its print, for example, method 1 for real service and method 2 of real service with some data passed to it, just to simulate methods where you pass some data into it. So let's say this is your client right here. So your client interface, I think this was named required interface in the class diagram. So let me rename it to that. So required interface right here is an abstraction, and this is what you expect. This is what the client expects your service to look like. It expects your service to be used with these following method names, method 1 and method 2. So to disguise your service instance, the incompatible one, as required interface, what you do is you create this adapter right here. So your service adapter will now realize your required interface, and inside your service adapter is an instance of the abstract service that is incompatible with the client that is intended to be used for. So you can see that as an attribute right here. This self.__ service right here is initialized from the constructor right here when you pass the service that it wraps or that it encapsulates. And the behavior of your service adapter, since it is disguising to be required interface but acts like abstract service right there. So all you have to do is to delegate all of the calls for method 1, since method 1 is supposed to be service method 1. So you call service.service method 1. For method 2, you do something similar. It is service.service method 2. So in the same way, a VGA cable, for example, can be disguised as a HDMI cable through an adapter. You can also disguise your abstract service or your real service using this service adapter. It is now disguised as required interface. And in the same way where you can plug this VGA cable into a laptop with a VGA port, you can also use this service adapter into a client that expects required interface, because polymorphically, it is required interface. So moving on to what the code looks like. So you have here S, which is an instance of real service, and you have here A, which is an instance of service adapter. So let's just add some type annotations for this one to make it clearer. So let's say S is of type abstract service, and A is of type required interface. But it was actually a service adapter disguising some real service. So a.method1 right here is called, and what will it do? I've already ran it a while ago. So when a.method is called, it will just delegate that to the embedded service inside your adapter. So your adapter contains an instance of real service that would be S right here, and it will call its version of service method 1, thus printing method 1 of real service. Similar thing happens in method 2 right here. Method 2 will just delegate it to a call to service method 2. And you can see that performed right here. So when this is called method 1, so your service adapter will just call service.service method 1. So what does service method 1 do? Print this one. Therefore, you get that specific print right there. And that's how it works. It's a very simple but very widely used pattern because it solves a lot of problems and incompatibilities between interfaces. So the example that you're gonna be doing for this exercise is actually very simple set as well. In fact, it's actually surprisingly simple that you're probably just gonna write less than 10 lines of code for this one. So the example, printable shipments. Looking back at our first lab exercise, so this is like a callback. So the last lab exercise for the design patterns uses the first lab exercise for design patterns. So looking back at that lab exercise, some of the example classes contain string representations, but they do not implement the str function. An example of this is shipment back from the factory method example. It does contain a string representation, and that is from the builder method called shipment details right here. But printing shipment is quite tedious since you have to print s.shipment details. So what you can do instead is replace the name of shipment details right here to __str to make it printable and stringable. But doing this change will potentially affect other clients of shipment. Maybe shipment is used by your other parts of your system, and it uses this specific print right here. It expects this name for the older parts of your system. You can add the str function, which does exactly the same, but what that will do will introduce unwanted code duplication. So if you just copy the contents of shipment details and place them inside a new str function, then that would just be code duplication, which is again bad for maintainability. So the best and easiest solution for this problem is to create an adapter for shipment called printable shipment. Printable shipment will realize some printable abstraction, which only does one thing. It contains the method str. And it's very simple. You actually only have 3 classes right here. So the shipment right here will only be provided to you. This is the same code that I've written for the factory method lab exercise. And you have shipment details here that returns a string. But let's say your client expects this shipment to be printable. It wants this shipment to be used just like other classes that implement the underscore underscore str function, meaning you can call print directly to the instance and you can concatenate it, and you can format the string, and uh, you can easily convert it to string using the str function call like that. So what you do is you create an adapter. So this one is the adapter. It is called the printable shipment because it is a shipment but it's now printable. So this printable shipment will contain right there a reference to your shipment, but it is a realization of printable, meaning it will be forced to implement this str right here. So you have to make these 2 classes right here. So maybe it's probably more than 10 lines of code because you're gonna be doing two classes, about that amount of lines of code anyway. So this is what is going to be provided for you, the shipment class right here. There you go. So you can just add more lines of code right here, add the printable shipment and the printable classes. That's up to you. You can add that to a different file, which is what I did actually, and then just import those files. Let's look at how it should work if you complete this lab exercise. So this is just preparing the order right here. This is just the same code I did for factory method because your shipment needs order, date, and etc. So I've created these ones right here. So to convert printable shipment or to adapt, or sorry, so to adapt shipment into printable, you create an instance of printable shipment, which is again the adapter. And you place inside printable shipment your service right here, or your, in this case, that would be shipment. You place that inside printable shipment. So meaning your printable shipment initialization should expect to receive a reference to your system. So meaning since this instance called PS right here is now printable because it has a reference, or it can be called using the underscore underscore str function. Therefore, you can now call print to it like this. You can directly print the instance without calling shipment details or anything else. So just to demonstrate this one, so there you go, that's the print. So this was supposed to be the return for printable shipment, or sorry, for shipment details. So by making it printable, we can automatically print the instance itself using Python's built-in print function. And again, the reason for that is because underscore underscore str is supported by your printable shipment. And that's it. So why is this elegant? Open close principle. Instead of changing existing incompatible interfaces, instead of changing code that you've already written, you can extend them instead by creating these adapters. And instead of cluttering up your code with duplicate functions and unused interface methods, you can instead create adapters, and you only do it when it's needed. Another thing that's elegant for this one is that You can also create other printable things if you've already created a printable interface. So, for example, the other older classes in your system, for example, the monster classes in your Abstract Factory lab exercise, the the commands, I think those were not printable. So what you can do to make them printable, basically to give them string representations, is to make them realizations of printable as well. So for example, in the bootleg text-based Zelda game, you have the class monster. If you want them to be printed directly using the print function, you can also make it, oops, not that. You can also make a printable monster adapter for that. And you can just realize that you can just make this printable monster a realization of printable and compose the monster inside this printable monster adapter right here. And doing that will automatically support printing of monsters through the printable monster adapter without even changing any single line of code that you've already written so far. That's what's elegant about it. You can extend the capabilities of your monster or your shipment by adapting it with these printable things. And that is all for adapter pattern, and that is also all for uh, design patterns as well. There are other design patterns in this lecture notes. I may delete them once I give them to you in the form of course packs, but I've decided not to include them for several reasons. One reason is to lessen your load so that you have less things to worry about. The composite one is a bit big, and another reason is because the composite part requires some knowledge about data structures because this composite right here is a tree structure. So you might find it a bit challenging implementing composite right here because it's basically a tree data structure. And if you haven't encountered that so far because of the asynchronicity of our situation, so yeah, it might not be a good idea. Also have facade right here, which I've also skipped. It's very short and it's very simple. You can just read this yourself. It's I don't really need. I found out I don't really need a video for this one. And that's all. Thanks everyone for tuning in to this course pack. Hope you're having a good pandemic vacation or whatever. That's all. Thanks, y'all.